All right, let's talk about something that sounds like it's straight out of science fiction, but it's happening right now. What happens when AI starts designing itself? Today, we're diving into the incredible story of neural architecture search, a technology that is completely rewriting the rules for the future of artificial intelligence.
I mean, really think about that question for a second. For so long, the progress of AI was limited by us, by humans. It moved at the speed of our best ideas and our biggest mistakes. But what if you could take the human bottleneck out of the equation? What if you could let AI take the wheel and figure out how to build a better version of itself? That's exactly the wild idea we're going to unpack.
Now, to get why this is such a huge deal, you gotta understand how things used to be. The old way of building AI was, well, it was brilliant, for sure, but it was also a massive roadblock. It was holding the entire field back.
Yeah, think of it like this. Building a top-tier AI was like hiring a world-famous architect to design a custom skyscraper. It was an art form. You had these brilliant experts who relied on years of experience, a ton of intuition, and just a feel for what would work. They'd spend months, sometimes even longer, tweaking and refining a single design. It was amazing, but it was also painfully slow and totally unscalable.
So, faced with this bottleneck, some of the smartest people in the field started asking a really powerful question. What if we could automate the architect? What if we could turn this slow, intuitive art into a super fast, repeatable science? And that's where neural architecture search, or NAS for short, comes in. At its heart, it's pretty simple. It's a way to automate the design process. Instead of a human, you have an AI system that explores a mind-boggling number of possible designs to find the absolute best blueprint for a given job. So how on earth does it work? Well, it boils down to a pretty slick three-step dance. First, you define the search space. This is basically your box of AI Legos, all the possible layers, connections, and operations you can use. Second, you need a search strategy, which is the clever way the AI decides how to explore all those countless combinations without getting lost. And finally, you have a way to estimate performance, which is like a rapid-fire judging contest to pick the most promising designs without having to fully build and train every single one. The first attempts at this were honestly incredibly ambitious. The researchers were basically making a huge bet. They wanted to prove that a machine, an algorithm, could do more than just match a human expert. It could actually beat them at their own game. And to do this, they drew inspiration from some really cool places. One approach was reinforcement learning. You can think of this like teaching a puppy. An AI controller proposes a design, sees how well it performs, and gets a reward, a virtual treat, if it's a good one. Over time, it learns to propose better and better designs. Another popular method was using evolutionary algorithms, which is just like it sounds. It mimics natural selection. You start with a whole population of random AI designs, and only the fittest ones, the best performers, get to reproduce and pass on their traits to the next generation. So, did it work? Oh, yeah. It worked better than anyone could have hoped. These early NAS systems didn't just meet expectations, they shattered them. They designed networks that set new world records on classic benchmarks like the CFAR-10 image dataset. They even discovered new, creative building blocks that no human had thought of before. This was it. This was the proof that automation could officially beat human intuition when it came to designing AI.
But there was a massive catch. This incredible success came at a cost that was, well, astronomical. Finding just one of these amazing new architectures required an insane amount of computing power. We're talking thousands of high-end GPUs running nonstop for weeks. It proved the concept was valid, but it was so expensive that pretty much no one could actually afford to do it. Okay, so that was the next big problem to solve. The AI community knew they had struck gold, but they had to figure out how to make it affordable. They needed to make this whole process faster, smarter, and way, way more efficient. And the breakthrough came from an idea called one-shot models. It's a seriously clever concept. Instead of building and training thousands of separate models from scratch, which is incredibly wasteful, you build one giant super network that contains every possible design choice inside it. By sharing information across all these potential paths, you avoid relearning the same things over and over again. And the difference this made was, frankly, ridiculous. Just look at this chart. This one-shot idea didn't just trim the costs. It slashed them by a factor of 1,000. A search that used to take months of computer time could now be done in a couple of days. This wasn't just an improvement. It was a revolution. It was the moment automated AI design became practical for everyone.
So making things 1,000 times cheaper is great, but this was about more than just saving money. This efficiency breakthrough unlocked the true potential of automated AI and started a ripple effect that we're feeling across the real world today. Just take a look at NASnet. This is one of the most famous models to come out of this new, efficient approach. It didn't just beat the best human designs on the super tough ImageNet benchmark, it did it while being 28% more efficient. It needed 9 billion viewer calculations to do its job. That means it uses less power, gets your results faster, and can run on smaller devices. And the coolest part? The designs it discovered were so good they could be reused to make other AI systems, like those for object detection in cars, way better too.
So what's the bottom line here? This automation is how we're getting the incredibly powerful and specialized AI that's becoming a part of our daily lives. It's what allows us to build AI that's tough enough for huge challenges like scientific discovery, but also lean enough to run right on your phone. This levels the playing field, so it's not just tech giants who can create world-class AI anymore.
So we come back to this simple definition. It sounds so straightforward, right? But now you know just how much is packed into that one sentence. By automating the design of AI, we're not just getting slightly better AI models, we are fundamentally changing the speed of progress itself.
And that leaves us with one last, huge question to chew on. We've officially kicked off a feedback loop. We have AI designing better AI, which will then turn around and design even better AI. The question is no longer if things will get faster. The question is, what happens to our world when the pace of innovation is no longer limited by the speed of a human mind?